Now, so the next section, now I'll upload this code. So export. Hopefully I did this the right one. I didn't know. Bollocks. Okay, so this is 8.1. Right. So now, yes, Kieran.
Say line 215, say the 4 there, right? You've got 4, 5.
Yeah.
Sub 5 is the iteration, right?
Yep.
And this, you've got 2 there that list files.
Yeah.
Where's the list files coming part?
Well, list files is so. That is a directory.
Yeah.
Okay. What directory is it? It's that guy.
Yeah.
Okay. Now, list files is a command or is a method of the file class. Okay. And what it does is it lists all the file objects that are inside this directory. Okay. Now, because when I did it up here, this guy up here, it produces this, which is all of the file objects inside this directory. The 7 of them. There's 4 files and there's 2 directories. Okay, so that returns an array that contains all of the objects inside this directory. Is that okay? Yeah. Okay. I just need to export this file. Because I exported in the wrong place. Right, so the next section we're going to do.
Sorry,
yeah.
This file generates an array, is that what you're saying?
Yeah. Yeah. So I should put that in there. So this generates an array. Strings, which will be the, sorry, this generates an array of file objects, okay, which are all the file objects contained within a particular directory. Now, so the next section is new. So we go new, we go Java project, we go F8.2, it's introducing streams. Yeah, introducing streams. No, so this is how we interact with files. All right. So inside introducing streams, we're only going to have 2 files, but one of these files is going to have a huge amount of text. So I'll just go through the text with you. So com.android. And we have a main and examples. Oh, tomorrow's only Thursday. I kept thinking tomorrow's Friday. Now, so here is the comment. It's huge. So let me just see. I'm gonna put this in main. Now you don't have to copy this down. You can just download the code, right? Now, first things. These are not the same as data streams from chat before and are totally unrelated. They use the new stream. Okay, so these are not the same as the data in chapter 4. I'll show you they use the new stream API and generate data. So the other stream API, or the other stream we're talking about, okay? That is the stream API that generates data, that creates something, okay? These streams are for taking input from somewhere else and outputting to somewhere else, okay? So these streams, so they're called, the official name for them is stream IO, okay? Are all about input and outputting data from external sources, such as a file and or from a user. Stream IO does not generate data, but gets the data from an external source. Put this in here. Okay, so the Stream API, Java 8 Stream API, that is for generating data. The Stream IO, that is for getting data from external sources. That's for outputting data to external sources. Now that can be a file or a user. Okay, so that can be a file or a user. So Stream IO does not generate data. Now, can you use streams with files? Yes, you can. Of course you can. Okay. Now it's unfortunate they're both called streams. All right, because it does cause certain confusion. All right. So this comment is really long, so I'm just going to copy it and I'm going to upload it. All right. I don't expect you to type this all out. So it's a long comment. It's probably the longest comment I have. All right, so it's 117 lines long. Now, so the contents of a file may be accessed or written via a stream. All right, now, so you could have 1 terabyte file and your machine could have very little memory. All right, now when they're talking about memory, they're talking about RAM primarily. All right, now, if you're reading a file, if you have something that's reading a file, and if the file is 1 terabyte, you might only have 2 gigs of, you might only have 1 GB of RAM. All right, now a 1 terabyte file is 1,000 of those. Okay, now it would be a huge Word file, for instance, but your computer can still read that file. You might have a computer that's only got 1 gigabyte of RAM and has got 500 megabytes of main memory. Oh, well, you'd never have 500 megabytes anymore. 500 gigabytes. 500 gigabytes of hard drive. All right. So, so we have 500 gigabytes of hard drive and we have 1 gigabyte of RAM. Yes, it can read a 1 terabyte file. The reason it can do that is because of something called streams. I know, because what's actually happening is it's reading 1 small bit at a time. Okay, it's not reading it as 1 big 1 kilobyte chunk. It's actually only reading it, let's say, at a couple of kilobytes a time. Okay, might be only reading 4 kilobytes a time. So it's a stream, a constant stream of data that's being produced. Now it's not saved as it's being read. So if you're just reading it, it's not saved, right? It's just, it's being read to your machine. Now, this is where the term streaming comes from. You know, Netflix and all them, it comes from computer technology, because that's what's happening there as well. When you're watching Netflix, it doesn't download the whole file. It downloads 1 bit at a time. It downloads it as you're looking at it. All right? So it is effectively a stream that's flowing through your display. Okay? Now, streams allow you to do, so file streams, You have a 1 terabyte file. And as it's been, you've got only 1 gigabyte of RAM, which is 1,000 times smaller than that. You've got a 500 gigabyte hard drive, which is half the size of that. It can still read the file. Now, it can't save it to your computer, but it can read it.
I know that with the RAM on its own work, because it would only take in 1 gigabyte speed at a time.
Well, no, it'd be less than 1 gigabyte. It'd be only a couple of kilobytes.
It could go theoretically.
I think it's up to a maximum of 2 gigabytes. I think. I don't. You can set the stream size. You can do that, yeah. I don't know what the theoretical limit is. I think it used to be 2 gigabytes. It might be more now. But there's no reason why you couldn't have it, let's say, 50 kilobytes. So everything is sent across in 50 kilobyte packages. Okay? Just like in networks, you know, stuff is sent around in packages. Streams are packages. Same thing, really. Okay? So streams enable us to deal with this file as we're only focusing on one small bit of the file at a time. Just like a stream of water flowing through a channel that allows, say, 5 gallons a second. This channel is not dealing with the entire contents of the stream, just 5 gallons at a particular point in time to the closest second. Okay? So you have a 1,000-gallon drum of water. Okay? And you have a pipe that length of pipe can take 5 gallons per second. Okay, so that is 200. So in 200 seconds, it will drain. Okay, but at any particular point in time, that pipe is only dealing with 5 gallons. All right, that's the same principle as streams. It doesn't deal with the whole 1 terabyte file. It just doesn't deal with 1 terabyte. It deals with maybe 1 megabyte a time. And there's a million megabytes in a gigabyte. So millions. What's a million millions? 1,000 millions, a billion, trillion. There's a trillion of those in a terabyte. Oh no, there isn't. There's 1,000 megabytes in a gigabyte. Yeah, so there's a million megabytes in a terabyte. Okay, so if your stream takes 1 megabyte at a time, at any one point in time, that stream is only going to, now it's dealing with 1 megabyte like that, right? Thousands of a second, all right? But you can change that. So that pipe only has access to 1 megabyte, so that's your machine. So it has access to only 1 megabyte at a time. It only needs access to 1 megabyte at a time. It doesn't need access to all of it. All right? Now, so when a stream begins processing a file, it has no idea when the beginning or the end of the file is. It just processes 1 data block at a time. Okay? So again, you have your pipe. All it cares about the machine, it doesn't care how big the file is. All it cares about is what's happening in here. Okay, now there is something called a pointer to our current position in the stream. Now, you have to be able to know what's gone before it and what's gone after it. All right, now that's done via something called a pointer. It's just a marker of where this part of the stream, of where it is in the overall file. That's all it is. Okay, it's just a marker to say where this particular part of the stream is in the overall scheme of the file. Now, so I go down a bit. Each type of stream segments data into a wave or a block in a particular way. Okay, for instance, some stream classes read or write data as individual bytes. Some read or write as individual characters. Some write as strings of characters. Okay? Some write groups of bytes or characters at a time. Okay? Now, if you have anyone that's writing in groups, be that strings, characters, they usually have the term buffered in them. Okay? So we have a file buffer reader. There's a buffer, I think it's file buffer reader and a file buffered writer. What they do is they write strings. They write a string at a time. Okay? Now they're high level. The more lower level are the ones that write in bytes. Now all the higher level ones are built on top of the lower level ones. For most of your usages, you're going to be using the higher level ones. Okay? For most of the things you're going to be using the higher level, which is the buffered readers, as they're called. The buffered readers and the buffered writers. But they're all built on the lower readers and writers. It's just have the term reader and writer. So file writer, file reader. They're going to be one that have bytes. The one that have buffered in the word are going to be the ones that deal with strings or characters. Okay? Now, all higher level streams are built on lower level streams. High level streams are more convenient, i.e. handle every word in a text file. So we're going to be in text files and we're going to count every word in the text file. Very easy to do with the buffer reader. All you do is you set up a loop or a string and it counts. It goes through all of the words in the file until it hits the end of the file. Okay? Now, also, writing 1 byte at a time is slow in practice. Java application file system has to communicate for every byte as opposed to doing this for every particular chunk of bytes at a time. So imagine if you're dealing with words, okay? So with the word marmalade, okay? If you have a buffered reader and a buffered writer, it just has to communicate with your machine once. If you're doing it by bytes, it has to do it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. So if you're using readers and writers, they are slower. But remember that if you're using buffered reader, it saves everything as text. So you can save everything as text, by the way, and then you can convert it into, if there's another programming language or if there's some other sort of code that you want to, okay? There's plenty of compilers that will do that for you, all right? You don't have to do it yourself. You've been made to do it yourself, all right? Buffered uses strings, but let's say you produce a file that has just strings, right? But the thing is, it doesn't matter what sort of computer code you have, it's all going to be strings. Do you get me? Right. If I write right? Now, if I write that as 1 byte at a time, it's going to go, and that guy there, 1, 2, 3, 4, 5, 6 spaces as well, 7, 8, 9, 10, 11, 12. Okay? Now, if you use a buffered writer, it's going to write the exact same thing. Do you understand me? So you can write to a file, use a buffered writer, but it could be done the most complex coding, whatever. Writing is a string, but it could be saved as a Word document template, a Unity physics engine, which is it's a API for computer games. All right, so it doesn't matter. So buffered readers are faster. Jesus, no doubt about that. All right. Now, so deal with bytes low level, high level, is built on lower level. Now, slow practice, blah, blah, blah. Two sets of classes for reading and writing. So you have readers and you have writers. Now there is something called read and write. They're a combination of the two. But the two basic ones are reading and writing. So you would have a buffered reader, you'd have a buffered writer. All right. So if you have a reader, you're going to have an equivalent writer. Now, reader does exactly as it says in the tin. It reads from a file. A writer does exactly as it says in the tin. It writes. Okay. Now, we're finished for today, folks. So I'm going to continue on the explanation, and then we're going to start using streams. Right, so Kathy, so you'll be here, you'll be online here as well tomorrow. Is that okay?
Yeah, that's fine.
That's good. All right, so Kathy, we'll see you then.
Okay.
Bye.
Say bye.
So we will stop the